width, with which we can change to 6 or 7. And we have our slope, which we can increase or decrease. And then we have our contour height. So we can kind of, visualize things a little bit that way. We can adjust how our topography, the detail of the topography, change some colors, and also baking out that path and baking out the, contours or topography. So let's look at this in perspective and see what's happening. So if I zoom in, I can see that I have a curve that is, zoom in here. I have a curve that is being represented, but it's three-dimensional, right? The curve I'm drawing is flat currently. And then the path itself is three-dimensional. And it does that by starting with a beginning point, so we can move that point up and down. You can see how that immediately affects the path curve. And then, or path's elevation rather. And then if we duplicate all of these things, if I just hold Alt and drag, it will duplicate all of the underlying geometries, but it will make now 2 patch interventions into the existing topography. So if I sort of look at this in perspective again, I can make this path sort of sit closer in space to where it needs to, and it starts to look a little bit more correct. So let's have a look at the Grasshopper. Much like in the patch topo mod mini workflow that we do, we have geosets to create our existing and our proposed topography. The only thing we're using in the proposed topography and the patched topography here is a patch boundary. And that boundary gets duplicated. Like whenever I duplicated my path, I also duplicated the path boundary here. That's a determination of how far out the interpolation of the path grading would go. So I can select different points here and move this out, and it changes that. Now it's going to depend on what the closest points are in some cases. So you have to pay attention to that. But yeah, it begins to tie it into the grading. So the way that we determine a path is using the center line, and that's a 2D curve, and then a bottom spot, and then a width and a slope. So if I can make the slope 5 here, and we can see that that's now steeper. We can use different kinds of curves. So let me go and plan here. So if I create a polyline, and I want to make sure I'm on the right layer. That's always important. So I'm on the center line layer. And it's drawing a path. That path is going to use the closest bottom point it can. So if I provide a new point on the bottom spot location here, it's going to change which bottom spot that it's using. The other thing is you can see that it's not affecting my topography. That's because we have not drawn a boundary. Let's draw a boundary just to demonstrate. So you don't need one boundary per path, but the way I'm sort of doing this example, it's sort of how it's working itself out. The other interesting thing is if the directionality of this curve affects the directionality of the path. So if I hit flip, if I type flip, it's going to flip the direction of the curve, and then it's going to find the closest bottom point. Looks like we're having a little bit of issues here. That doesn't happen too often, but it looks like it's certainly happening there. I'm wondering if it has to do something with the bottom point. I don't think so. The other thing to look out for, and if you ever have a issue, you can always do break a path into a few segments. The other way to look at this is you could bake out just the path. You could use this tool to get paths that have, path segments that have different slopes, and you could build those, and then you could pull those in as other geo into another topo script. So this could be a utility for building paths rather than thinking of it as a, this is not going to be a catch-all topography script. But one of the things I wanted to point out was if I do a fillet or fillet corners, which will do more than one corner, you can do fillet corners, and then we're going to say give it a 10-foot fillet. The neat thing here is that the slope, and it's a little hard to tell, but the slope on these fillets are actually a little less steep, because what it's doing is it's looking for the shortest side, and it's making that the side that's being used to determine how much of a height difference it's going to have. That means that the path flattens out a little bit, but it also means you're not going to exceed the slopes. And so it's really great because it kind of figures out that grading for you. As long as you have a path that can have equal segment sides. If I were to take this and scale it down and make it really small, the width would suddenly potentially prevent this from working out properly, right? So it's too tight, and I would need to think about bigger radii on this curve. But in the meantime, this kind of scale works much better. And you can see, obviously, the longer the path, the higher the rise on the overall path. So yeah, so that's paths in the topography tools of LandKit. Enjoy.